Hello everyone. I am Imran Ahmed. I'm a student of Biomedical Engineering Department of Military Institute of Science and Technology. Here, I'm going to give a presentation on magnetic resonance imaging, or which is known as MRI. So let's start our presentation. Magnetic resonance imaging, MRI. What is MRI? MRI is a non-invasive medical device. An MRI, or magnetic resonance imaging, is a radiology technique scan that uses magnetism, radio waves, and a computer to produce images of body structures. So it's a medical device, and this device uses the technique of magnetism, radio waves, and computer to produce an image of our body. It is also known as nuclear magnetic resonance, or NMR. Here is a picture of an MRI machine. History of MRI. In 1924, Pauli suggested that nuclear particles may have an angular momentum. In 1937, Rabi developed a method for measuring the movements of atomic nuclei and decided to call nuclear magnetic resonance, or NMR. In 1972, Damadian patents idea for large NMR scanner to detect malignant tissue. And finally, in 1973, Lauterbur published method for generating images using NMR gradients and renamed NMR to MRI. So this is the history behind today's MRI machine. Use of MRI. So at the start, we learned that MRI is a medical device. So let's see how can we use MRI in medical sectors. It is often used for disease detection, diagnosis, and treatment monitoring. It produces high-resolution images of the inside of the body that help diagnose a variety of problems. So it is a device that helps to detect the disease, diagnose the body, and monitoring treatment. And it gives us this information via good quality images. There are the problems which we can detect from MRI, like inflammation or infection in an organ, degenerative diseases, stroke, tumors, musculoskeletal disorders. Basic components of MRI: magnetic field gradients, radio waves, computer. So these are the main four components that makes the MRI machine. Here is MRI scanner cutaway image. Here we can see the components like scanner, magnet, gradient, coils, radio frequency. So magnetic field. Magnet is the most important component for magnetic field. MRI requires a magnetic field that is both strong and uniform to a few parts per million across the scan volume. The field strength of the magnet is measured in Tesla. The magnet currently used in the scanners today is 0.5 Tesla to 2.0 Tesla in range. So for magnetic field, we have to use strong magnets, and these magnets has to be very uniform in strength, and the strength is measured in Tesla, and the strength we use in today's MRI machine is about 0.5 Tesla to 2.0 Tesla in range. Magnetic field gradients. A magnetic field gradient is a variation in the magnetic field with respect to position. Magnetic field gradients are needed to encode the signal spatially. Gradients are simply loop of wear or thin conductive sheets on a cylindrical shell that lies just inside the core of an MRI scanner. So a magnetic field gradient is used for variation in magnetic strength in different positions, and it helps to encode the signal. And it is a loop of wires which is inside the core MRI machine. Here is a picture of a magnetic field gradient. Radio frequency coil. Radio frequency coil is another component of MRI machine. So let's see what it says. Radio frequency coil is used for producing radio waves. Radio frequency coil, RF coils, are the antenna of the MRI system. It broadcasts the RF signal to the patient and receives the signal from the patient. So from the definition, we learned that MRI uses the radio waves. So these radio waves are signaled or produced by radio frequency coil, and it is called the antenna of the MRI machine because it is the component that sends signals to the body of the patient, and it also receives the signal from the patient. That is why it's also called the receiver. Here is a picture of radio frequency coil. Computer. Computer controls the activity of the whole MRI machine. It can control the gradient coil and RF coil for acquiring data. It interprets the signal received from the RF coil, and using complex algorithms, it processes image of the body. So we can say that computer actually controls the whole MRI machine. It can control the gradient coil and RF coil, and with higher complex algorithms, it can process the image of the body. Here is a picture which shows that computer helps to produce images from MRI machine. Principle. MRI uses the magnetic property of certain atomic nuclei. For clinical MRI, it uses the magnetic property of proton because proton is in water molecules, therefore in tissue of the body. Using strong magnetic field, hydrogen nuclei is aligned. The nuclei can be rotated by using radio waves. The radio waves excites the atom. When the atoms are going to stable situation, it also emits a signal energy. The signal is received by the receiver coil. Signals are interpreted by high algorithms and image is produced. So the principle says that MRI uses the magnetic property of atomic nuclei. Then in clinical MRI, it uses the proton's nuclei because in our body we have lots of water and water contains proton. And when human body is placed in a magnetic field, it makes the hydrogen nuclei to be aligned. Then this nuclei of hydrogen can be rotated by using radio waves. When the radio waves stops, then the energy received from the signals of the body, it also starts to emit energy from the body, and those signals are received by the receiver coil. Then the signals are interpreted by high algorithms and image is produced. Here, the picture where we can see randomly arranged hydrogen atoms before placing it into the magnetic field. But when we place the atoms or the human body, the magnetic field, it is aligned in a certain direction, and this direction is to the direction of the magnetic field. How does MRI work? Patient is sent into the magnetic field. Then most of the human body is made up of water molecules, which consist of hydrogen and oxygen atoms. When one lies in the powerful scalar magnets, the protons in patient body line up in the same direction in the same way that a magnet can pull a needle of compass. Radio waves are then sent to certain areas of the body, knocking the protons out of alignment. When the radio waves are turned off, the protons realign. This sends out radio signals which are picked up by receivers. So we can see that when the patient is in the magnetic field, the protons in the human body start aligning in the certain direction of the magnetic field. When the radio waves is sent to the areas of the body, then the proton changes its direction and it aligns in a new direction. And when the radio waves is turned off, the protons comes back to its original position, and at that time, those protons send signals which are picked up by the receivers. These signals provide information about the exact location of the protons in the body. They help to distinguish between the various types of tissue in the body because the protons in different types of tissue realign at different speeds and produce distinct signals. In the same way that millions of pixels on a computer screen can create complex pictures. So when the signals are received by the receiver, those receiving signals vary from time and those things gives information about the position. And the computer do this thing overall every time and gives us the complex picture. Here is another block diagram where we can see a patient is lying on the patient table. There are radio frequency coils, there are gradient coils, and there are the magnets. And with these influences, they get information, and those information are carried to computer, and computer do the processing and give us the images. MRI interpretation. As MRI is about interpreting the condition of the body via images, there are mainly two ways to interpret images. Those are T1 weighted image and T2 weighted image, which is also referred as T1 image and T2 image. To know about the T1 and T2 image, we need to know some definitions. T1. T1 is actually a longitudinal relaxation time. It means that the time constant which determines the rate at which excited protons return to equilibrium. T2 is the transverse relaxation time. It is the time constant which determines the rate at which excited protons reach equilibrium or go out of phase with each other. Repetition time, TR. This is the amount of time between successive pulse sequence applied to the same slice. And finally, time to echo, TE, is the time between the delivery of the RF pulse and the receipt of the echo signal. T1 weighted image. T1 weighted image is one of the basic pulse sequences in MRI and demonstrates differences in the T1 relaxation times of tissues. T1 weighted images are produced by using short TE and TR times. magnetization in the same direction as the static magnetic field. It is also referred as T1WI, or the spin lattice relaxation time. Here is a picture of T1 weighted image. T1 image properties of tissue. It means that T1 image has some specific properties that gives information. In this T1 images, CSF, which is known as cerebral spinal fluid, looks dark, white matter looks light, cortex looks gray, fat looks like bright, and inflammation looks like dark. Usefulness of T1 images for assessing the cerebral cortex, identifying fatty tissue, characterizing focal liver lesions, gives anatomical information. So with the T1 images, we can get these 4 helps in the medical sector. T2 weighted image. T2 weighted image is one of the basic pulse sequences in MRI. The sequence weighting highlights differences in the T2 realization time of tissue. T2 weighted images are produced by using longer TE and TR times. It is also referred as T2WI. So it is the image that highlights the T2 realization time of the tissue. Here is a picture of T2 weighted image. T2 image properties of tissue. In T2 images, CSF looks bright, white matter looks dark gray, cortex looks light gray, fat looks light, and inflammation looks bright. Usefulness of T2 image. We can detect edema and inflammation. It reveals white matter lesions. It helps assessing the zonal anatomy in the prostate and uterus, and gives pathological ideas. Here are the T1 weighted and T2 weighted images side by side. That gives us the idea, which actually looks quite opposite of one another. Types of MRI. So there are mainly 2 types of MRI, which is open MRI. In open MRI, low magnetic field strength made by permanent magnet, and this is the picture of open MRI. It is usually used for claustrophobic patients. And there comes closed MRI. In closed MRI, we need high field strength of superconducting magnets. This is the picture of closed MRI. MRI contrast agents. MRI contrast agents are contrast agents used to improve the visibility of the internal body structures in magnetic resonance imaging. The most commonly used compounds for contrast enhancement are gadolinium-based. Most clinically used MRI contrast agents work by shortening the T1 relaxation time of protons inside tissues. MRI contrast agents may be administered by injections into the bloodstream or orally. So MRI contrast agents are some special contrast agents which helps to give better visual images. And in MRI, we use basically gadolinium based contrast. How does it work? It helps by shortening the T1 realization time of proton inside the tissue. And these contrasts are administered into the body by injecting into the bloodstream or orally. Here is the picture of MRI contrast agent. Advantages of MRI. MRI has advantage of lots of things, especially it provides high quality images for diagnosing different parts of body and tissue, has the ability to diagnose, visualize, and evaluate various illness. It is non-invasive and doesn't use ionizing radiation. So we know that MRI gives us the image of the body, and those images can be used for diagnosing different parts of the body. And it can also help to evaluate various kinds of illness. And another advantage of MRI is that it is non-invasive. It doesn't have to penetrate our body, and it doesn't use ionization radiation. This means that there are other medical imaging modalities in which the ionization effects are used, but in MRI we don't need ionization. We use magnetism. Disadvantages of MRI. Yes, there are some disadvantages of MRI. Let's see. It is very expensive. It is risky for patients with metallic device in the body. Movements during test may give blurry image. RF signal might cause burn if mishandled. Yes, MRI is a very complex device. That's why it's very expensive. It is risky for patients who have metallic device because MRI is a magnetic device, and those magnets might affect the metallic device in the body, and it has an effect in artifacts because MRI takes about 25 to 30 minutes to scan, and it is tough not to move in this long period, and if we move it might affect the image and it can give us the blurry image. And RF signal is very strong, and if it is mishandled it might burn the body areas. Safety. MRI is painless and safe procedure. Yes, because it is a non-invasive device, so it doesn't need to penetrate our body, so that's why it's painless. Research has been carried out into whether the magnetic fields and radio waves used during MRI scans could pose a risk to the human body. No evidence has been found to suggest there is a risk. So there is no risk of magnetism, and radio waves for the body. Risk. As MRI uses powerful magnets, the presence of metal in our body can be a safety hazard if it attracts the magnet. Even if not attracted, the magnet metal objects can distort the MRI image. Yes, because MRI is about a magnetic field, and those magnets attract the metallic device in our body, and those might affect our body, and it also affects the results. There are devices which can be affected for MRI. Let's see. Metallic joint prosthesis, artificial heart valves, pacemaker, metal clips, cochlear implants, metal pins, screws, plates, stents, or surgical staples. These things might affect our imaging process, and it might affect our body too. So this is the risk for MRI. Recent advancement of MRI. The most recent advances in magnetic resonance imaging technology have been on the software side, enabling faster contrast scans, greatly simplified cardiac imaging workflows, and allowing MR scans of the lungs. Many popular companies are claiming about their achievements like multi-contrast MRI images from a single acquisition. Lung MRI now is possible. Software greatly reduces MRI scan times. Silent MRI scanning, simplifying cardiac MRI. These are the recent advancements of MRI. Here is a link where you can learn more about the recent advancement of MRI. Future of MRI. MRI is the most flexible of our diagnostic imaging modalities, possessing the ability to characterize a wide range of pacemaker parameters in the living subject and provide exquisite spatial resolution. So it is believed that in next 10 years, MRI will be more advanced, like a widespread shift to a higher field imaging, improvements in MRI coil technology, the introduction of ultra-short echo time imaging, the introduction of combined modality methods like positron emission tomography PET MRI and a single photon emission CT SPECT MRI. Significant advances in molecular MRI agents. So these are the expectations in next 10 years for MRI. Reference. These are the links where I collected the information about MRI, and thank you for listening.